All right, hello. Good Saturday um, afternoon. I actually have I had my birthday last Monday. I'm 41 years old now. But my birthday present was like 2 hours alone in the house today, which is like that's what it's like. But I'm spending one of those hours streaming. Mm, and I had a reflection. And that reflection is related to actually it's I think maybe this will be one of my better uh communications or delivery of how I think app development is very different and why we argue so much about like state management and how to do it, because I think a lot of people uh hey, hello there, happy to see you. Anyway, so a lot of people they think about apps as having like a backend, some API, and it can be REST or GQL or whatever, right? And then your application is just some components. And let's make that blue. And the point of this drawing is that whatever this API gives to the components, it's like a one-to-one mapping, right? There's nothing like the thing in between here, which is like state management, is like it's almost non-existent. State management, like it doesn't even exist, because you can do something like what's it called, tan query, or like the query thing, where you basically just hook directly into your API, and then it will take care of like the management of that data. And you're happy, right? Any state management you need, you can just do within the components, because it's all about just syncing the data from your backend. And a lot of applications works like this. And this is why you put something like Next.js in there. It's to make that data synchronization more efficient, right? But at the end of the day, you're not really doing state management the way I think about state management, because I haven't been working on apps like this. And I think about like the primary like domain of applications is like e-commerce, right? That's a very good example of an application that works this way. It's like super like non-existing state management. It's just about syncing the data from the backend with the components. And something like TanStack query is like excellent for that. But then there's this, another aspect of this is that the way we develop this is that maybe you're working alone on an app like this, and you're like a full stack engineer working on the back end and working on the front end. So we kind of call this the back end, right? And then we call this the front end. But as the complexity of the app increases and like there's a team, what typically happens is like you'll have, where's the circle? Where are circles? How do I draw a circle? Is it here? There we have circles. Is there like a shortcut for circle? I think I need to move back to Excalibur. Whatever. Was it O? Yeah. So you have a person here. This is how I draw people. Like that. And then I make this one a tiny bit darker. Let's do this. Like this is a backend person. Yeah, that's nice. So you have some people here, and then you have some engineers here on the front end, right? And they collaborate. They talk to each other. The backend takes care of the concerns of like managing data towards the database and tries to give an API that's best suitable for the app we're making, right? Oh, hi. Yeah, there's a release coming very shortly. So it supports React 19, actually. So yeah, it's coming. But yeah, awesome to hear you've been using Overmind. Awesome. Yeah, and please ask any questions as I'm doing this. But yeah, I'm just dumping some reflections here. So as the application scales, you'll have like specific people working on the backend concerned about the database towards the API and trying to give what the app needs from the API so that it maps like well to like basically product needs in the actual application. And then you have the front-end engineers that takes in that data, builds up the UI and the user experience, and they're concerned from the consumption of data all the way out to like the color of like the CSS color property, right? But the kinds of applications I've been working on isn't like this. It's much more like your API is kind of like, it's a tiny thing. Like it's a tiny piece of it. And then the state management is the beast of it. So it's more like this. So, and what typically happens here is that this also becomes smaller. So it's more like this. Yeah, whatever. And the reason it's like this is because the application isn't about synchronizing data primarily. It's about managing a shit ton of client state. Like it's an editor type of experience. It does include some data synchronization, but even that data synchronization, like the way that data is presented in the UI might be so complex that you can't get an API to kind of provide that through a single endpoint. You have to like manually put it together. And it can also be based on the kind of backend solution you're using. For example, I've been using Firebase a lot, and there's some restrictions to how you like organize the data. And if you have very complex data, like in the family app, you need to bring this data together in the client and then provide it. And the reason I'm saying this is that the way I think about building applications like that is that you kind of get another layer of people here, or there's an opportunity for it. And we've often used this term like the back end of the front end. And then this is UX. And when you work on applications like this, there is an opportunity to divide the team once more, so that the backend team is concerned with like databases and providing the data as efficiently as possible to the client, but it's not driven by the components or like the UI. It's more driven by what the state management tool, or sorry, the state management layer needs, or state layer, or whatever you want to call it. And then you have engineers working on the state management, and they have the same idea. Like they care about the data that comes in, and then they build up like endpoints or an interface for the components to most efficiently manage their state, right? So components just becomes like UI and CSS. They don't do state management, they don't do data synchronization, they don't care about that at all. They only care about building the UI. And then all the complexity of like data synchronization and managing all these client-side states, putting data together into like more complex data representations, all of that happens within state management. And their promise to the components is to give like an API that's like tailored for that final product. And this is how I've been working historically. And it's just because of the type of application I'm building. It's not this type of application, it's this type of application. And that's what everything has kind of, everything I've kind of talked about and built tools on is based on this experience. Including this, like the Bonsify thing that we're playing around with. It's just to give a way to manage this if you build an application that requires it, or if it just fits your mental model, right? Yeah, so that's what I wanted to dump. And I thought maybe we could write a little bit about it before we jump into some by the way, the last thing I want to say is, like, to work like this is really, really fun. And it's not about like the state management people talking to the backend people and the UX people talking to the state management people. Like, everybody talks about everything, right? But when it comes to exact implementation, there you split up the concerns so that the UX people can completely dive into UX complexity. And there's enough in HTML and CSS alone and just building components that's enough to worry about. And then state management like focuses completely on how to implement the best possible, like getting some data, managing that data with all the other client-side state, and providing that like super efficiently to components, and so on. Ignoring guarantee. I think I'm gonna. I got a little bit intense on this thing, I think. So ignoring guarantees. Let's see. I have to move my thing here. Like, we're often taught that certain are there to create guarantees. For example, went on somewhat of crusade. Mutability is bad. Okay, so, but stating that mutability is inherently bad and immutability is inherently good is, well, let's keep it for now. It's absolute. I want to tone down a little bit, like not say bullshit, but it kind of fires me up. So it does represent how I think about it. We're also taught that reducer has a guarantee. I shouldn't say ignoring. That's what I want to change. It's not about ignoring guarantees. It's about what was the term I used? It's like when you have to do it. I can't remember the term. So one thing is if it's up to you as developers to bring guarantees into your code. Another thing is to be like restricted or forced guarantees. Yeah, that's what I meant. Forced guarantees. We have to. Yeah, we don't have to say that. Force guarantees. Yeah, let's just do that. And then bull dust. Yeah. Yeah, I think I can write this better, but working in teams. The reason you reach, well, many applications has 3 layers. Data, or I'm not sure if I want to write. Do I feel like writing? You can think about applications as having 3 layers. Data, This is your server providing persistence. Providing persistence. The interface with this data are REST endpoints, GQL, or similar. State management. This is where you manage data sync. Or maybe I should write components first. Components. This is you can think about many applications only needing 2 layers. The interface with data are REST endpoints, GQL. Yeah. This is where you build up the UX. And with Du må komme ned, Emma! Drar du? OK, ha det fint, da. Ha det. This is where you build up the UX. You can think about... No, I don't feel like writing. I feel like coding. Yeah, I just want to dump my thoughts and then, yeah, let's just commit that. Oh. Sorry, I'm kind of... It was so cold here this morning, so I thought I had put on a bunch of clothes. Anyways, commit directly. So what was I gonna say? Yeah, it's nice. Like, it was nice just dumping these thoughts, and then we'll see what comes out of it. But I kind of wanna rather code. So last time we got stuck on a bug in the observer package that just makes observation like completely transparent. And I wonder if it's fixed. Yeah, I think it is. Oh, that was a weird thing. Okay, nice. I think it's fixed. Yeah, it's fixed. That's nice. But we're not gonna actually work that much on the UI. We're rather gonna be working on the state management. So if you didn't follow the last stream, this is the app we're kind of re-implementing. Just imagining what state do we actually need to make this app work. And as we talked about, this app has like a session. So you can't use the app without being authenticated. So all the state management that's related to the actual app is behind the authenticated state. And then we talked about like how you navigate this app. Like, for example, the groceries list is not part of the shopping list view itself. It's actually, it's just state that's available all over the app. Because you want it to be available at any moment in time. So these are not like pages. This is an app, right? So all the data is always available. And a lot of it actually needs to be available on this front page because you have this calendar that shows you all the to-dos for today and even the dinners planned for today and stuff like that. And related to what I talked about in the introduction, like the complexity here, is that I'm using Firebase. And if I were to use Firebase directly with the components here, I could definitely implement the app. That wouldn't be a problem. But there's a lot of complexity to the data that needs to be handled. And then there's also a lot of complex interactions, like planning next week. Like each user can like commit to a certain day for each to do. There's like, it's a complex UI. And it's definitely a contest. Anyways, a type of application where you would want to bring in that state management layer and just make the components super, super clean, and rather put that complexity into the state management layer. And that's exactly what we're doing here. And the way we do that is that we have our state folder, which has an index file where we actually create a session. Because as I said, the app is behind the session. So the app only instantiates its state management when you're actually authenticated. And this is useful, especially if the app, you're going to be able to like sign out and someone else is going to sign in. So in this session, we have like authenticated, authenticating, unauthenticated. And as you can see, authenticated gives you the family Scrum app. But what's important here is that this family Scrum instance that we're creating, which we're creating down here on the authenticated state, it can be disposed because it's subscribing to a lot of data. So as you can see here, whenever Firebase changes its authentication, we check if the current state is authenticated yeah, sorry. So I'm not sure if Firebase is actually able to move you from authenticated as one user into authenticated as a different user, but I'm just handling it as like, we don't trust anything. So if the user changes to a different user and we're authenticated, we're going to dispose of family Scrum, which means that it unsubscribes to all the data synchronization. Everything's like gone. And then it sets up the new user and moves us into the authenticated state. And if we don't have a user, oh, I actually forgot that. And if we don't have a user, oh, wait, this logic is actually wrong. Let's fix it. Oh, I don't need this. Let's make it a little bit bigger. There we go. So how would I best describe it? It's kind of weird that, you know what? I think this is a little bit overkill. Like you can't be authenticated and suddenly be a different user. You have to be unauthenticated first. So I think this is completely overkill. And then, so what we can rather do here is maybe, you know what? Let's keep the if, but let's remove this and this. And no, maybe user. We're gonna say session state family Scrum dispose. So what this means is that if you are currently authenticated, but there's no authenticated user anymore, we're gonna dispose of the whole family Scrum thing. You know, this actually fits better down here. We're gonna do this, this, this. We're gonna return here, and then we're gonna do this. That's better. So if we have, you know what we're also gonna do? We're gonna flip this around because this other code is much longer. So if no maybe user, yeah, I don't like nested ifs. But I think like since this code is so much longer than the other one, I think it's important to like highlight it. And then we'll return here instead. So if there is no user, yeah, I guess I don't know why I get stuck on these things, but I just do. It's just how I do things. So if there's no user and we're authenticated, we're going to dispose of the current app. And then if we don't have a user, we're going to say we're unauthenticated. And then we just return. Or we'll set up a new family Scrum. Oh, yeah, you see the local storage here? Yeah, it depends on what you actually store. Like this user is just like user details. Like I can't even remember what it was. Users, where is it? User DTO. User DTO. Yeah, it's just the ID of the user and the family ID of the user. You can't really do anything about that. But if it was like some private data, like the name of the user, their email, stuff like that, you can. I often think about authentication as an app running on a public computer, like at the library, right? So when you sign out of that app at the library, it should be completely clean, right? But again, in this case, it's just the user ID and the family ID, and that's not important because that's typically part of the URL even when you do REST calls, so it can be like picked up by people. But yeah, if it was private information, it shouldn't be there in local storage, definitely. Yes, and the reason I do this is just because Firebase has some latency to checking the initial authentication. So typically with Firebase, you are actually authenticated. So I kind of, with local storage, I kind of just fire up the app with the assumption that we are signed in, which we typically are. And then it would sign out and become unauthenticated as soon as this callback triggers. Oh yeah. Okay. Anyways, but it's a good point. Like it's something to be careful about. Where were we? Yeah, so that is how this works. And then this index file, that just creates the initial state for the app, which is the session. And then it exports hooks. So whenever I want to use the actual session, I give it the session. And if I want to use Family Scrum, like it's actually been authenticated, it renders out the app. I want to be able to, I have a lot of components that just want to access Family Scrum. And then I create a hook for that. But it checks if the session state, like you could say this should really be like session, use session. It's a little bit silly since it's just returning the session. But you can imagine yeah. Yeah, maintaining state sync between backend and frontend is a huge pain. I know there are solutions for this. Like there are specific like I can't remember the name of it, but it literally is like you can have like a Postgres local database that just syncs with an external database. So manually keeping data in sync is very challenging, and that's also why I think we have like these two classes of applications. You have big data complexity, and the UX is just syncing with that data, right? That's all the UI really is. There's no like much state management in between there. The complexity is in the data. And then you have these other kinds of apps where the complexity isn't in the data. There's very little data synchronization happening. But the complexity is in the app itself, in the state management of the app. And maybe there are classes of apps that has both. And I guess that will be the trickiest ones to handle. You can even think about VS Code itself, right? You can't, it doesn't make sense to build VS Code with TanStack or what's it called? React Query, right? That doesn't make any sense at all. Why use React query to build VS Code? But having a good tool for the state management of VS Code, that makes a lot of sense, right? Just like in an e-commerce site, you would use React query, but you wouldn't put like the state management of VS Code into an e-commerce app. That doesn't make any sense. Anyways, so we have, this is how we kind of allow components that we know is in the right state to consume, or they are rendered because they are related to like this state of being authenticated. And this has been like my biggest, like talking about the biggest nightmare. For me, the biggest nightmare has been managing state, like making components understand their broader context. So a component is like this isolated piece of code that knows nothing about its surroundings. Like that's the composability of components, which is great. But what if you want those components to render in the context of having a user as opposed to not having a user? If your application is built in such a way that it's literally typed as having a user or not having a user, it means that when you consume that user state in one of your components, you literally have to check if the user is there, or you'll get a TypeScript error. So the component doesn't know about its broader context. And that has been super painful for me. Figuring out like, how do you make the components understand their broader context? And I feel like this is somewhat cheating. And this is not because of this tool. This is like, even with a context provider, like your components doesn't know that they have a parent context provider, right? But you're using hooks as if they have it. So there's no contract between the local component and its surroundings. It's very implicit and it bothers me. I wish there was a way to make components, like have an actual like type contract between a component and its its parent hierarchy of like state. But that doesn't make any sense. It seems like that would completely break the good thing about a component, which is being completely decoupled from everything else. So you can compose it wherever you want. But there's just something about that. But anyways, so this would indeed throw an error. If you use family scrum in a component that's not being rendered in an authenticated state, you would actually get an error. But the typing is correct. And the same would be for use dashboard here. So we only have like one view open at any time in this app. Like you can see here, either I'm on the groceries list, I'm on the checklist, or this view, or whatever. So I only have one view open at any time. So, and that's reflected in the state. So if we look into family scrum here, we can see that we're going to look through this shortly. But in family scrum, we have the user, we have the family, and we have the current view. Oh, didn't I actually... Wait. Why isn't this up to date? What the hell? Didn't I commit that? Nothing to commit. But I added... What the hell? Sorry. Oh, it's called unsubscribe. Sorry. Sorry, I forgot this. Wait. Oh, Don't, I'm not returning it, sorry. Oh, silly me. Sorry, we're gonna go through this shortly. I'm just gonna data lot and subscribe. So with this family scrum, I only have one view at a time, which means that if I were to consume the family scrum state in any nested component, for them to know, like they don't know which view is active, right? They have to check. So if I have a bunch of components that's only rendered in the dashboard state, I create a hook for it. So this uses family scrum, and then if the current view isn't the dashboard, I'm going to throw an error so that the state I return from use dashboard is a guaranteed state of being in the dashboard. And again, like this is a thing I'm not sure how to solve this differently. Like a way to create that contract between like components and its state is props passing, right? But that's exactly what we don't want, because props passing is just shit. Maybe there's a better way of doing props passing. It's almost like, what if you could define, like, because you define props, right? It would be so interesting if you could like define a context as well. Like, so it's not props from apparent components, it's like props from apparent context. And then somehow there will be like, you will get a warning if that component is composed into a tree that doesn't have that context. Like that would be ideal, I think. Because then you wouldn't have to do these things. Then you could just say in a component, my component, you can say, okay, this is parent props and this is like context props. Where parent props is direct props from the parent, and context props is a contract with some provider of, or like whatever, like context state or whatever. Some state provider by some context provider. That would be really, really interesting, because that would keep that contract, but I have no idea how that would actually work. Yeah, it's interesting. Anyways, yes, where were we? Okay, so I guess another piece of thing I haven't mentioned here is that when we create this session, is that we pass in APIs. I'm just calling it APIs. So this is Firebase, and we have a camera API to use the camera on the computer. And so doing that, we are creating this state machine of an authenticated, authenticating, authenticated. We're grabbing these collections so that we can actually handle the authentication change. Yeah, so the thing I'm building here now is kind of like a global big object, which is just composed together. And each hook here, I'm just kind of mapping what I'm doing here to your statement. Yeah, and then so each hook kind of maps to a nested level of that tree or a specific state of the tree. So as I mentioned, like family scrum has a view, and so that view can be in like have different nested objects, right? Based on it being a dashboard or groceries or whatever. So each hook maps to like a piece of that state tree, but I think often And that's also part of the story here. I think often we think about these global state trees as just like being one, you can represent it as one static tree, right? The only thing that changes are the values in the tree, but the tree itself is consistent. But in this world of like state machines, you're having like unions of states, your tree isn't static anymore, it's dynamic. So if you imagine like this application as like in a debugger, the way that tree would look like initially is like, sorry if I'm going on a tangent here now, but the way this tree would look like initially is like it would have a session, and that session would have a state, and the current state of that session would be unauthenticated. That's basically how this state tree would look like. If you were looking at the UI, it would also reflect that, right? But then as you click like sign in, for example, well, I guess another thing here is like, and it has a sign in function. That's how it looks like. But then as you click sign in, it moves into authenticating. And then when it's authenticated, suddenly you have family scrum here. And in family scrum, you have like a view or whatever, or like you have whatever. You have the current view, and then the name of that view might be dashboard. That's the current view. And then it has some state, for example. So that's the thing I've kind of, when I built Cerebral and Overmind and used that to implement solutions, like the trees were very static, and that's like a good thing. Like it's good for your mental model to have a static tree where you can just imagine the values changing, but it doesn't represent the reality. Because what you could have done here to make it more static is that you wouldn't have this session. You would rather have user DTO or null, for example. And then you would still just have, for example, a dashboard. So you would have dashboard, maybe you would have groceries here. Like you would have everything there. It's just not like initialized yet. But that's also what's like creating the problem, because the tree doesn't reflect the dynamic nature of the app. So I have this struggle, like I want to have a strong mental model that correlates to the actual behavior of the app. But if it's so dynamic that you can't ever like actually see the state tree for what it is, it's also tricky. And it's reflected in the code as well, because if you made your state tree static, you could literally in your code just describe the default initialized state of your whole app, right? It would look something like this. And that's a really good thing for your mental model. But it sucks for your code, because especially, that's why I have such a love-hate relationship with TypeScript, because TypeScript is the thing that started this whole thing for me. Because without typing, you're never aware that your components doesn't understand the context they're in. Like, you have a component that wants to use the user. You know that that component can't be rendered without the user. So you just go into your state tree and use the user, and you typically don't have a problem. Maybe you'll get a bug. Like you were looking at a user and the user wasn't initialized yet. A very typical bug without typing. And where was I? Yeah, exactly, TypeScript. So without TypeScript, you can have this static representation of your tree, and it's very, very helpful for your mental model. But with TypeScript, you're kind of forced to describe the dynamic nature of the app to make the typing correct. And that kind of just hurts your mental model, I think. And it also hurts your code, because your code now has to describe much more in detail that dynamic behavior of the tree. if that makes sense. Algebraic data type. That sounds very, I've heard a term. Let's ask ChatGPT. What is algebraic data type, and what and how would you express them with TypeScript? By the way, sorry for the small letters on ChatGPT, but I don't know if they support. Oh, you can make it bigger now. You couldn't do that before. That's nice. Are compromised type formed by combining other types. They come into. Oh, yeah. So they're like unions. Yeah, exactly. Oh, yeah. I just call them unions. So yeah, and they are great, right? They actually describe that dynamic nature, just like the session here, right? So the session can be authenticated, authenticating, or unauthenticated. And the session state can be either of those states. And it just beautifully describes the dynamic nature of this app. Even when you read the code, right? But this is great. Like, this is very, very readable. But then you get into the actual code. So you have to express how to produce the unauthenticated state, the authenticating state, the authenticated state, and then how you move between these different states, as opposed to just having a user. Do I have a user or don't I have a user? Like, it's so much simpler, but it completely breaks your components, because with strict null checking, like if you turn off strict null checking, then this wouldn't give an error. Like, let's just write it out. Const state. So function my app. So return user, like state.user.name, whatever. So if you turn off strict null checking, this would just work. And it would likely work as well, because you understand the relationship between this component and the rest of your app. You know that the user exists there. But with strict null checking, you will get an error there. So you would have to like override, no, there's a user here. Or if state.user is null, return null. Like, that's what happens when you think about your state as something static. At least in my experience. So I think you're perfectly right. Like, if you call them algebraic data types or like unions, like, they do describe this dynamic behavior really, really well. And they're beautiful for code in the sense that, just like the example ChatGPT gave, like it allows you to explore within the code what's available to you in these very explicit states. So here I know that because I'm checking if we're authenticated, that there is an actual family scrum there, which is also great. But it's also not great. And it's because of the components, I think. And also that you have to, like, because of the decoupled nature of components, but they should be decoupled. So it's not about like saying that components are wrong, but it's just, yeah. And then how you actually need to go about expressing these states. So I'm kind of, yeah, it's very interesting. And this is a, like, calling them unions or algebraic data types. Like, these are low level programmatic concepts that applies very, very well to many situations. And I think for state management and UIs, it's relatively unexplored. Like David K. Piano with his X state and state charts, I think he's kind of been the large, like the big voice of thinking explicit states and state machines and state charts, and they make so much sense conceptually. It's just, yeah. Yeah. This is such an interesting discussion, and I'm not sure what's most helpful. Yeah, exactly. So yeah, so this is like, just to add to this, like this impact React.dev project. Yeah, exactly. So this impact React project, that was based on like your statement, Adam. Like, okay, we don't like working with the primitives of React. Like the state management of React runs inside this reconciliation loop, and it adds a lot of complexity and mental meltdown when you do that. So even when you put your state management into a context provider to share that state across components, that's still very complicated or very complex because of the primitives of React, and the context provider runs inside the reconciliation loop. So what Impact tried to do is like, okay, that's a really great concept of like, you start out your app with creating a session context, and that holds the session stuff. But then the components take over. So you have a component that switches on the union of states, like authentication states. And when you are authenticated, it mounts a new context provider, which is your actual app, or whatever that means. Maybe it's even a router. So like each route has its own context provider or whatever. The point is that there's more like this handoff between the UI and your state management. And what Impact does is it just makes that context provider reactive. So you don't have to use React's primitives and use them inside the reconciliation loop. It's like a reconciliation loop less context. So you can use normal reactive primitives. You can use Bonsify with this. I could add Bonsify as a library here. Anyways, so I think that makes a lot of sense, because like it makes a lot of sense, but it still doesn't solve the problem of nested components. They don't understand that they are a nested child of that context. So you would still have to do this check, right? So even if you used like nested context in React to kind of share state, you would still have to do this kind of thing where like, okay, I'm going to use the family scrum context, but instead of checking on the state, you will be checking on like use context, family scrum context. And then you would say, if that context isn't there, throw an error, right? Because you might use that hook in a component where that context isn't provided. So it's kind of the same thing. It's just that here we're kind of just building up the whole application as a tree first, and then the UI just derives from that. Well, if you use context providers like in Impact, then it's more of a handover. Like one context for session, the components are responsible for what happens next, where they mount the next provided state. And I don't have like any strong opinions about either of them. I've always liked the idea of being able to build your app without thinking about UI. Also like my little brain dump in the beginning of, okay, if it's a complex enough app, it would be nice, kind of like how you divide work between API and client, or backend and frontend. You can also divide work between state management and UX. Yeah. But I wish there was a way to create a stronger contract between components like the only contract a component can create now is a contract with its parent. Like that's how we can think about it. That's props. It's the contract with the parent. And the problem of having, and that contract really solves the problem. But the side effect of that is that you have to do a shit ton of props passing. That really is the you know what, I feel inspired. Let's just, instead of playing with this app, let's play around with this idea. So we have this we have this we have this style things like styled.div or whatever, right? It would be interesting if we could, I don't even know how to express it in code. Yes, yeah, so that's a good point. Like, and that's what I'm kind of going with here, is like, if you use a reactive state, if you use reactive state management, your props passing becomes insanely more efficient. One thing is that you don't have to pass like separate props. You can actually safely pass objects down without any issue. And the other thing that it solves is that these objects, they rarely change, right? So for example, if you have a list of items and each item state is a reactive object, when you pass that object down to the item, the object itself never changes. If that changes, it means that the item isn't there anymore in a reactive world. So you just automatically optimize everything. So to put it in a different way, if you were to pass like a root state down as a default prop to all your components, that doesn't mean that all components re-renders every time something in your state changes, because it's reactive. It's only based on what state they actually access from that root state. And that root state will always have the same reference. It's just an object that will never change. Sorry, I suddenly got cold again. So what I was reflecting on is like, what if there was a way to like in a function, in a component, to be able to say, like, you have your props, but one of those props is like your state. If that state is like a root state, or it's like one of these unions, that would create the contract. Yeah, you would. Yeah, exactly. You would only pass down the subsection, right? So in this code, you see like root state, but it could be like the dashboard state. It could just be the item. Like, it doesn't matter. But it's kind of. But the point is that it needs to be a contract with, like, if we're going to use the prop as the contract, it has to be easier to pass state down through the props. It's almost like, the reason I picked up on, maybe I can just try to describe this as how should I put this? It's almost like you kind of you create your app, and then you give it the state, right? And then you kind of create the components from that app, if that makes sense. So app would be app component. And that would give you could even have like normal props, and then you could have the state of the app like this. So this is only about like exploring contracts. This is not like, I'm not saying this is a good API. It's just, how would you guarantee that contract? And then, yeah, and the point is, yeah, no, this would be very difficult. Because then what you kind of would have to do is like, how would you guarantee that? Well, I guess what you would have to do, okay, so what you kind of would have to do is be able to express, how the hell would you do that? Okay, just to, so I have this other component that, like, so, okay, so a normal component, like some component, normally the contract would be you passing foo bar. That would be the normal contract. But if, and for one level, it's fine to just say like state, whatever. But the problem is when you have this state is going to be passed, like every single component, like the deepest component needs access to the state. So you have to pass it down and pass it down and pass it down and pass it down. It's almost like if I created some component, no, like I can't wrap my head around this. I don't, like, how can that some component, like what I would want it to do, like what I would want it to do is that I would want some component to error. Like this line should actually error if it has a dependency to some state that's not being provided by this component. I can't wrap my oh. Yeah, like I don't think this makes any sense. Yeah, I have no idea. Like this is just a higher order component, right? It doesn't create a contract. It just provides the state. The contract needs to be, it's not in the component, it's in the consumption of the component. So some component, like some component, like this is where it needs to know. There is component-based state, which is kind of relevant to the structure, but if something at the bottom needs something at the top. Yeah, exactly. It's more global. But then it might be that nested component might need a specific, like let's call it union or state of that state. Like it requires it to be authenticated or it being on the dashboard or some feature is active or some mode of that feature is active, right? And if you go and grab the global state, then you have to check all of them to get down to the correct typing. But I'm like, but it has to be possible to say that. Well, I guess what you kind of have to do is like, it's almost like state state dot component. Like you would kind of have to do some like that's kind of like the type of thing you will have to do to kind of create that guarantee that, okay, I'm actually providing, I'm consuming a component. Yeah, so you have to flip it around. So the component does state what parent state it depends on, But since we're not like passing props here, like we don't want to do props passing. Like there's no way around this. Like you have at the consumption point, that's where you have to make the contract real. Like it doesn't make any sense. You have to do props passing. Yeah, but yeah, exactly. But what if that deep nested state wants access to the user, which is something that's tied to which is a property on the root global state? You would have to pass the root global state down, all the way down to that component, right? But if it only needs its most immediate state, then it doesn't matter. But if it needs like something higher up in the state tree, it's interesting. It's almost, but it makes me think about something. What if you had a state tree where you had reverse lookups? So if you were at like the dashboard, so you have state like session, and then you're doing this state tree thing, but then you're at like dashboard, and then for some reason you have access to this dashboard state. You would also be able to like do dashboard parent, and now you're on session, and then you're on parent, and then you're on root. So you could do like, so if you do pass nested state, you can always walk back up. I think there's a concept for this. Where was that? Is it Mobix state tree that allows that? I think so. Mobix state tree, parent state. Get parent. Yeah, you could pass. You can pass root user to, you mean to the component? You could, but then you have to pass user all the way down. Like if you have 50 components nested, every single component has to pass that user. Yeah, it's interesting. Like being able to walk back up the tree. That would definitely remove, you know what? That is a solution to the problem. Like whatever you're doing, if you're so you wouldn't, but still you would still have to rely on props passing, but not to the same degree, because you could always safely like pass down nested state, and then any nested component consuming nested state, they will be able to use that state to walk back up the tree to get access to other state. But that would create a strong contract, because then if, for example, let's say you have like so thinking about like unions here. So let's say you are like authenticated, you have the app, you look at a specific view, you look at a specific feature, the feature is in a specific mode, and all of these are unions, right? And then you have a component in that specific mode, and it wants to access something at the root of your state. So you can like look at that specific union of that mode, and then it just dot parent, it would get to that specific feature, dot parent, it would get to that specific union of of the view, so that specific view, and then dot parent, that will be the specific session state, and so on and so on. Yeah. So like, yeah, and you could choose that, like, who does the walking? Is it yeah, that doesn't matter, right? Either component could choose. It depends on what the consuming component is, I guess. Like if the consuming component only needs the user, you can choose if you want it to take like the full state or just the user state. It gives a lot of freedom. But it's a very interesting concept, like trying to solve contracts between components and a global state and not having to pass a shit ton of props. That's a very interesting way to do it, having that parent relationship. Yeah, so there's no hook, right? It just deals with props. And as it's reactive, you this is very interesting. But it's a pattern, right? It's like maybe we could let's see. Can we write it out somewhere? Let's create a file. We're gonna do it. We're gonna create a file. Test.ts. Oh, look at that. Failing on creating the file. Close others. No. No. Okay, so if I were to use like const app reactive, I'm just gonna implement it because I would assume, Adam, that you literally like because you're class based, right? App, and then in the constructor you get the parent, so you kind of say public parent, some parent. Like this could be the session, for example. So each like class has its parent. So if you were going to do this as like a pattern based approach, like not like a, I guess it's a pattern approach as well. Like you can do it with MobX. It's just, yeah, it's just giving access to the parent for every level. It's very interesting. So if we create, well, again, let's use session here because it is this, I want to test one thing. You know what? We already have the state here. So we have session, but what we're going to do is when we create family scrum, we're actually going to pass in, yeah, 2 seconds. Let's see. So we're going to do this. So this might be a little bit verbose, but we're just going to test it. Return. So this would be, let's just call it state reactive. And then what we would do is get family scrum. And then we would, let's see, we would do return family scrum. And then we would do const family scrum equals create family scrum. And we would actually pass it state. Let's see, APIs. This will be a little bit long, but doesn't matter. APIs state. And then we return the actual new state. So the point to kind of test here really is, let's see, where is the family scrum? So here the parent would be authenticated. Oh, aren't we exposing that? Oh. So we're saying authenticated, and then we're saying parent would be authenticated, and then basically parent here. Oh, what are you complaining about? Oh yeah, sorry. So that's like how you do that is how you do like parent. Like it's easier in a class in a constructor, because in a constructor you have access to the object before it's instantiated, kind of. But you don't have that when you just use plain objects. So this is how you, or at least one way of handling that. We don't actually need to do this. But yeah, it's very interesting. Giving access to the parent. Yeah, because I've never thought about, well, it's always been on my mind, like this, how do you create a strong contract between components related to like state that doesn't belong strictly to the parent and still avoid props passing. I would love to see it in an actual app. Like I wondered, like you still have to do props passing, but again, you get that strong contract. Yeah, it's very interesting. Yeah, I'm just thinking about the pattern. And I guess like even here, oh, did you send me a picture? Oh yeah. Yeah, root store. Yeah, exactly. And then you just pass this down to whatever nested state. Yeah, and then you have like, so the, yeah, root store. Yeah. Yeah, exactly. It makes a lot of sense. It does make a lot of sense. So even here, like I'm thinking about impact, where you rely on your components, like you have this model of still thinking contexts. It's just that the context is reactive, and then you would just pass like whatever parent you have. Like you would basically pass the like you don't even use context, right? You just pass your root state to the root app component, and then that app component will then pass, maybe that is doing some authentication evaluation, and then it will pass like the authenticated state into whatever store. So you would kind of have it here, and then you could always expose that here. So yeah, exactly. Yeah, that is the solution for the contract issue. That's for sure. I'm just reflecting on, like, it's very natural to do that with classes because you have a constructor. Yeah, I'm thinking about, like, the thing is that you have to, for the typing to work, you have to be very explicit about what's on the object. So you couldn't, like, in any way, like, it's very interesting. Like, technically, maybe it's possible to have this like hidden parent, because of this reactive function, right? You're kind of composing together nested levels, and maybe through the proxy, you would be able to expose like a hidden parent property that allows you to walk back up, but you would still have to type it. So you might as well, like, just add it yourself. But it's trickier, right? With just objects. Yeah, but even as a second parameter, the challenge isn't bringing the parent into the object. It's bringing the parent to the object. So yeah, I wonder if Legend does this. I'm just gonna ask ChatGPT. Let's see. Does Legend state have a concept of traversing back up the state tree using a parent concept or something? It's so funny. Like, it says okay, comma. Oh, it's too good. The set is designed around the idea of accessing via its defined path rather than maintaining explicit parent references. Each is essentially a proxy into a portion of your state tree, and while it knows its own path, it doesn't hold a built-in reference to its parent observable. Yeah, no, they don't have. From what, well, I trust this. Like, it even has a reference. Yeah, so they don't seem to have that. It's very interesting. It's very, very interesting. But the other interesting thing about this is, if you think about the mental model, like, do you build a state tree outside of your app, and then your app derives from that? So, like, your approach, Adam, having classes where each nested class has access to its parent class to create that child-parent relationship. Like, the components, they will still just derive from that, like, single global state representation. But there is this other mental model where you don't have like one root state. You have one state representing the session. In this case, let's just use those examples. That's one thing. And then it resolves to something. In this case, authenticated, and it holds like the routing part of the app, for example, like which view is active. Maybe it even holds all the data of the app because it's shared across all the views, stuff like that. But But then that's available in the component, and then the component passes that into a nested context, like with impact. So what I mean to say is, like, with that mental model of the handover between like a simpler state store, a component hands off some nested state to another simpler state store, which then uses a component to hand it over to another simpler state store. That would make it easier to create that parent-child relationship. Not compared to classes, because they are kind of built for this, but compared to like Bonsify here, having just plain objects. Yeah, it's super, super interesting. And as I said, like, Impact React isn't there for its primitives. It's there for this mental model of doing a handover between state and components. But then even here in the consuming stores, it's like you're using the App Store. But it's almost like, does it disappear? I don't know. Like, I use classes when I work, especially work on the back end. But they do become yeah, there's a lot of keywords. Yeah, because like with Impact, you're basically creating a context, but we're not really talking about a context here. Well, I think what I'm saying is, like, what the two mental models are, let's draw it. The two mental models are, I can have one big ass state tree like this. You know what my plan was today? I was going to stream for 1 hour, then I was going to make myself a pizza, and then I was going to play Path of Exile 2. It's not happening. Let's see. So let's just call it root. Yeah, who drives the state? And there are two models for that. Yeah, let's just write that. Who drives the state? So there are two models for that. Is it the state? Is it a root state? Damn you, Adam. Damn you. So do you have a root state? Let's just call it like global state tree. That's like one way of thinking about it. It being classes or whatever it is, it holds all the states, it has all the functionality, and your components, they just derive from that. So what happens is that you have your app, and then you have state, and you say root state. Okay? And you're done. So your components will just pass pieces of that root state down as props, right? And then with that reference back to the parent, like any nested component can look at any nested level of that root state, and they can walk back up. And they can also walk back up in the correct union, which is, or can they? Yeah, they can. Yeah, they can. So when they walk back up to the session, they'll look at that session as authenticated. It won't be a union anymore, except if they walk back up to the actual root, which has the session state. So if it walks back up to root and looks at session, it will look at the unions. But when it walks back up to session, it will only be that union of like authenticated, which is exactly what you want. Yeah, exactly. So when you walk up, you walk to the kind of, if you think about like your state tree, certain states within your state tree has unions, right? So it kind of spreads out into specific paths. So when like some deep nested component looks at one of these paths, when it walks back up that specific path. But when it walks up and down again, it starts like spreading into the unions again. It can take multiple paths back. So anyways, this is one way of thinking about it. So you pass in the root state, but then you can have, let's just call it handover. So in this case, you have like a session, for example. So this session does not include what state is created when you're authenticated. It has the authenticated state, but in the example of the app we built now, it doesn't have the family scrum property, right? It just moves us into authenticated. So what happens here is that you get like app state session, and then this session is evaluated. So let's actually write out the component there. So app gets session, which is kind of, yeah. And then it switches on that session, current, whatever. And then it's authenticated. And now this component is responsible for creating the next, for rendering the next thing. Let's call this session. Let's call this session as well. So now this is responsible for rendering out the app, right? But it would also be responsible for creating the state for that app. So the way you pass in the parent now is that you say state is create app state, and you pass in the session. And this session is now typed to the authenticated state, and that could be added to whatever state create app state does. The problem is, of course, reconciliation. So in solid.js, for example, this would work beautifully. But the whole problem with React is that you can't, like this will, just with strict mode, it will create app state twice. And this is what impact handles. It's like you can safely instantiate something once. Oh, but I hate solid. Like, I don't hate solid. I don't like reactive components. I like reactive state, but I don't like reactive components. That's a whole like value proposition of impact, is that reconciliation is great for components, for building UIs, but reactivity is great for state management. Yeah, but here is like, so yeah, so this doesn't work with React. That's the problem. Like, you would have to do the context provider thing. It really sucks. It really, really sucks. And the whole thing is like the only reason this is a problem is because create app state could have a side effect of like subscribing to some data, for example. But the good thing about this, and I think like conceptually, I like, that's what I mean about the handover model, that I like it better because you can think about your state, you still think about your state as domains and nested domains, but you don't have to express it as like a full state tree. Like it's going into your components at some point anyways. So just like, and I mean it from a code perspective. So session here, like how do you know where family scrum is coming from? Like you have to go into this session and then, oh yeah, it's coming from authenticated. But session can just be its own thing. It doesn't care about family scrum. It doesn't even care about family scrum being instantiated when it's authenticated. It's not really its responsibility. So it would be nice to be able to think about session as an isolated concept, and then the components, the way you build their components, it decides when and where family scrum is actually instantiated. Yeah. Wait, is it? Shit, how long have we been streaming? 1.5 hours. Yeah, but it's... Oh well. Yeah, it's... I can't settle on this. Like, we've kind of gone through 3 different things now. Like, we can have... Let's see. So what have we gone through? So there's a concept of a static global state tree. That is a good thing for a mental model because it means that like a unionless unionless global state tree. That is an amazing mental model because none of the state depends on each other. It's just, do you have a user? Don't you have a user? Okay, there's a dashboard in here. Dashboard. There's some to-dos in here. Like you don't know when it's instantiated, how it fills up, when it fills up. You don't care. Like it's just, there are some to-dos and that's how they look. And then you have like edit to do. That's something you can do. And then it has new title, which is starts out as empty, for example. Maybe IDE starts out as null or something. Like the point is you can just describe the whole thing, and you can also write this in code. This is really, really great. No, we're not going back to Vue. I was so saddened about all the weird stuff they do with props passing. It just completely breaks the mental model. But then you have unionful. And in this case, you can't have this static representation. Like you would start out with like session, for example, current authenticated, and you won't have anything else. Like given that the app can't instantiate any other state until you're actually authenticated. So you kind of break up that model. But then you have, let's see. And then you have this handover global, well, handover tree, handover, I don't know what we're gonna even call it. Let's just call it handover. So with handover, you can still have unionful. Like I'm making up shit there. So with handover, you would still like have these representations of, let's see. So you could have like session, like you have, the point is in a handover, you have session, but then you might have a different tree, which is like views or something, current dashboard. So with a handover, it's up to React to move you from one to the other, but they can still have like a parent to session, something like that. But it's React's responsibility, it's the component's responsibility to figure out when should these views be instantiated. The problem is that you can't instantiate shit in React because of the reconciler. Oh yeah, exactly. Yeah, union full. Let's call it authenticating. Yeah, so you have like multiple trees, and like you would literally have, so here you have one single model, right? But here you can have, like, I guess you multiply the number of states with any nested state. Like that can be a lot of views of that tree. So it just makes it more complex. While here, even though, so this is like, how should we say this? It's like, there's probably some mathematical thing of like, is it O? Can you use O here? Like O of states or something? O of unions? I don't know how you express this. Something like, I have no idea what I'm doing. So it's very hard to, yeah, represent that tree in your mind. But here, what you do is you rather do, so each thing has authenticating. So each one is just a union, right? So you reduce the complexity of each level of state. Yeah, but you can still walk back up. That's the beauty of this. Like both the state management, like the views here can point to the parent, and any component can point to the parent, which is kind of the beauty of it. Yeah. You know what? I've been working on a service at my employer. It's been such, like, I don't get into these, like, what the hell are we doing? How can we do this better kind of thing. I'm just doing the work and I'm happy with it. UI suck. But yeah, I guess the thing for reflection here is, where was it? The thing for reflection is, how can you do this handover with React in the reconciliation loop? I guess in this case, you could do something like, well, one thing that's interesting about this is like, yeah. Okay, so this is this is kind of a crazy thing. So what if we didn't do this? We did this. So you don't provide the actual state. How will we do this? No, this doesn't make any sense. No, this is weird. Yeah, what I was thinking about is like, what if you could do like you could actually use the object. Like the point being that you circumvent React, because this object doesn't change, right? So if you create you only want to create the app state once for every session object. But that might not be true for other things. Like if you want to create some state for each item, well, yeah, you want to use, yeah, again, like the parent is the same for every item, so it doesn't make any sense. Yeah, no, it really sucks, the reconciler, like in terms of state management. Ah, this was exhausting. But it's interesting. It's very interesting. I think I might still, I won't be able to eat my pizza, but I have some time for Path of Exile. I think I'm gonna do some. Path of Exile 2 is amazing. It's one of the, like, talking about complexity, like this stuff, it's just, like, imagine making a game, and a game like Path of Exile 2. Like the complexity of like balancing that game on top of like building a like a game like game engine wise, like consistent, like just how it feels when you play it. They've done an absolute amazing job. It's also interesting that all this stuff is because of unions. It's almost like you could isolate it to that's the problem. Yeah, it's interesting. Like I've been looking at game engines. I actually built a game engine once. It was like really shitty, but it actually had some cool features. You could like, I actually built a, oh, I wish I had that project still. So I built like this editor with the game engine, which was like pixel based. So you would draw like sprites, but when you drew the sprites, you would also draw a height map. So it will kind of make the make it completely flat with a gray color, and then you could change the gray color to change the height map. And that height map in the game engine would just basically decide what sticks through other things. So for example, if you drew a tree, you would have like the, what's it called, the trunk of the tree. It would have like so the trunk of the tree would have a low height map. Like it would have a very light gray color, but the like palm leaves would have a very dark gray color. So if you drove your tank, it would kind of, the tank would be in front of kind of the trunk, but if you drove underneath the palms, it will be under the palm leaves, right? And the same for like an archway, where it should drive in front of the wall, but if it drives through the archway, like the actual like arch thing should then be on top of the tank. But it didn't only have that, it also had a light map. So you had a third version of the sprite where you could, how did this work? Yeah, so you could, it would automatically generate shadows. So Yeah, it basically created shadows. It changed the light of the color based on that light map. Anyways, it was shit, but it was very cool. It looked pretty cool as well. Anyways, but I'm not sure like what game engines do. They have a concept called entity. That's kind of their Redux. I feel like not their Redux, but their like state management. It's like I can't remember the full name. It's called entity something. But it's based on, I guess the closest thing we get to it's when we do like denormalization. So you kind of spread out everything into these like records. So you can do like very quick lookups. Component entity something. I can't remember. But yeah, I think there's there's a reason why, like which game was it that actually went to React to build the actual menu of the game? I can't remember. I think it was a Call of Duty game. They actually used MobX and HTML web technology for the menu because it was so hard to do in their game engine, which is interesting. Like UIs, I think UIs are even more difficult than a game engine or like actual graphics and physics and everything in a game engine. No, it's not. But they seem to have sold it better than us. Or maybe not. Like there's a lot of rave about like how Unreal is like so bloated and it's so slow and just get back to the basics. I guess they have the same struggles. Yeah, fucking classes. Yeah, I think my head is fried. I wish I could like make any kind of conclusion. But this is more, yeah, this was very inspirational. I've never been able to like, I don't know if this even makes sense, but why like Cerebral and Overmind was so approachable. One thing is, like I know it's the mental model it created for people. I'm not saying Cerebral and Overmind was the only tools that could create that mental image, but being able to look at your app like this is very, very powerful. But it isn't correct. It doesn't represent the true nature of your app because you don't necessarily always have a user. In this case. So this is a better representation. Like your app can actually be in different states. Like your whole freaking tree. It's like parallel universes. But it's a much more complex mental model. And then you have this thing. Which I kind of think like the thing about this is that it doesn't allow you to just work on, well, I guess it does. It's kind of like you're making your state component based. So you're just saying that, okay, this views, it's its own thing. Like it's not instantiated by session. It's its own thing that anything can instantiate, but it depends on session to do so. Yeah, I think I'm gonna take a break. And let's just let all this ranting but this was super, super fun. This was super fun. Yeah, my brain is stuck. Cool. Yeah, please please connect with me, Ivan. Like it seems like this is a never-ending thing. But I like that's the funny thing. I feel like for every conversation I have about state management, I feel I learn something. And that's what makes it fun. But also frustrating. Like you think there is this like it's kind of like string theory. There's this like super minimal, perfect abstraction that just solves everything. Anyways, yeah. Good night and have a good weekend.